All right, let's dive right in. Today we're going to take a concept that seems super simple, a basic shape, and follow it all the way to numbers that literally never ever end. We're talking about the fascinating two-way street between squares and square roots. So it all boils down to a question kind of like this one. How in the world can a neat, tidy, predictable little garden square have anything to do with a number that just stretches on into infinity with no pattern? Well, that's the mystery we're unpacking today, and believe me, the answer is pretty amazing. Okay, so first things first, we gotta get a handle on what we even mean by a square number. What's the shape of a number? Turns out it's way more literal than you might think. Just picture a square. Let's say its sides are 6 feet long. To find its area, you just multiply 6 by 6, which gives you 36. And that's it. That physical shape is exactly why we call the number 36 a square number. Think of this as the first direction on our two-way street. When we square a number, all we're doing is taking a side length, like 6, and figuring out the area of the square it would make. Side length becomes area. Simple. And now for the return trip. The square root does the exact opposite. It starts with the area, say 36, and it asks a really simple question. Hey, what was the side length that made this square? And the answer, of course, is 6. But here's the thing. Not all numbers can make these nice, perfect shapes. So let's imagine there's this exclusive little group called the Perfect Square Club, and it's only for the neatest, tidiest numbers around. The main rule to get into this club is super simple. A perfect square has to be the area of a square whose sides are nice, clean, whole numbers. We're talking 1, 2, 3, 4. No fractions or decimals allowed. Check this out. If you have an area of 12, yeah, you can make rectangles like a 3 by 4, but you can never make a perfect square with whole number sides. So 12, sorry, you're out. But 16? Bam! It makes a perfect 4 by 4 square. Welcome to the club, 16. And here they are, the first 12 members of our little club. 1, 4, 9, 16, 25, and so on. Seriously, just getting familiar with these numbers is like a math superpower. You'll start seeing them everywhere. So we've gone from the side to the area. Now let's really dig into that reverse trip. The best way to think about a square root is as the ultimate undo button for squaring something. And this is the symbol that does it. It's called the radical. It might look a little intense, but all it's asking is a simple question. What number, when you multiply it by itself, gives you the number underneath me? That's it. This shows you just how perfectly they cancel each other out. Let's say you start with the number 8. You square it, you get 64. Then you hit the undo button. You take the square root of 64, and boom, you're right back where you started, at 8. It's a perfect round trip. Okay, but what about all those other numbers? You know, the ones that didn't get into the perfect square club? We can't find their exact whole number root, but we can do something really clever. We can trap them. Let's try it with an example. Take the number 21. We know it's not a perfect square. It's not on our club list. So what is its square root? How can we figure that out without just grabbing a calculator? So the first step is to find the two closest perfect squares that 21 is sitting between. And if we look at our list, yep, 21 is squeezed right there between 16 and 25. Now here's the really logical part. If the number 21 is trapped between 16 and 25, well then its square root has to be trapped between the square root of 16 and the square root of 25. Makes sense, right? And just like that, we have our answer. The square root of 16 is 4, and the square root of 25 is 5. So the square root of 21 has to be some number between 4 and 5. We've just narrowed it down big time with no calculator at all. So we can estimate it, which is cool. But what actually happens when we ask a calculator for the exact answer? This is where things get really, really weird. The calculator is hiding a secret. Let's ask what seems like the simplest question imaginable. What is the square root of 2? I mean, really, what is the side length of a square whose area is exactly 2? You punch it into your calculator and it spits out something like this, a long, long string of decimals. And then you see those 3 little dots at the end? Those dots are the most important part, because what those dots mean is that this number just goes. It keeps going and going and going forever. And not only that, the digits never ever fall into a nice repeating pattern. It's just an endless, unpredictable trail of numbers. And this kind of beautiful mess has a name. It's called an irrational number. And it turns out that the square root of any whole number that's not in our perfect square club is irrational. Hiding inside these simple questions are numbers of infinite complexity.
This also means your calculator is technically lying to you. It has to. Its screen can only show so many digits, so it has to chop the number off and round it. But the real true number, it never stops. What you see is just a close guess.
And all of this leaves us with a final, kind of mind-bending question to chew on. If a number's decimal form is literally infinite and has no pattern, can we ever really say we know it? We know its symbol, sure, like the square root of 2, but its full true identity stretches on forever. It's this perfect paradox, and it all started with a simple square.